Okay, are we ready to get started? Super. So before anything else, as we say, this is going to be an interactive course. There are some materials on GitHub that you will need in order to follow along. So these can be found the lower QR code here, or the link on the right here, go to GitHub here. And the slides to follow along can be found linked from the GitHub repository as well. So that should take you somewhere like this. You'll see on the link here, if you open this link, it will take you to the slides. You'll be able to click on the links in there, follow along with anything at your own pace, go back to slides you might have missed. And hopefully most people are reasonably happy with cloning a Git repository, but since we've got a sort of dependency gridlock with the Git courses being later this afternoon, I will briefly go through that for anyone who's not familiar. So if you drop down here, you'll see something to clone your repository. If you've got SSH set up, then you can use this one. If not, there's the HTTPS here. If you copy that URL and then go into a terminal, I'm assuming you have navigated somewhere where you want to put this code, and we're going to run git clone and that URL just there, which if we then let it do its thing and take a look, you'll see that we've now got that folder there. So if we cd into it, you'll see that you've now got all of the code that was here in the exercise. If you have just before we get started, a couple of other things. So in terms of behavior, there is a code of conduct for the summer school. Please, everyone, be nice. I would say also this is meant to be interactive and a learning opportunity. It's not a lecture. So if you've got any questions, please just stick your hand up and we'll try and answer them as we go through. And if you think it's a silly question, please try not to worry because someone else probably has the same question and doesn't want to ask it. So it's better to ask than not to ask at all. So just before we get started, this is a two-part course. Today, we've got a focus on kind of tooling for writing better research software, whereas tomorrow we'll focus a little bit more on kind of actually writing the code itself. So before we get started, or as the first thing, what is research software? Does anyone want to quickly volunteer any answers? Thank you. What sort of things might that be? Do you use research software? And what is it?
Mathematical models and analysis, plotting.
Yeah, okay, let's move on because that's exactly the answer we want, which is a lot of people, when we say research software, think sort of major computational programs. So these large models simulating the climate, running on high-performance computers. But really, this covers everything that might be used in any bit of research. So we also have kind of data processing, plotting, like you said, generating these sort of graphs to be interpretable, doing them in a way that's sort of reproducible and helpful for people to read. But also all the way down to experiment support. So when we think of kind of, if we have ocean cruises processing bottles over the side, or if we have large telescope arrays, all of these will have software in there to control them, to process the outputs, to link everything up. And so it's a very, very wide sort of field. And so the idea of the course today follows sort of this tenet of the Scientific Software Institute, which is with better software, we can do better research. And the idea of what we're talking about in this course is sort of trying to give you key tools and key skills to actually improve the code that you're writing on a day-to-day basis. As for why this matters, so sort of the horror story slide, I'll let you read this in your own time, but it sort of to summarize, there was a scientist who had found sort of groundbreaking evidence of new protein structures, published all of this stuff, was on a high-flying career, sort of multiple Nature papers, got his assistant professorship, and then it turned out no one could reproduce this work. When they burrowed down into it, the data processing had been done in Excel, and there'd been 2 columns that had been flipped upside down. And so everything sort of to that point came crashing down because the results were null and void. And sort of the lesson to take from this is that hopefully these sorts of mistakes can be avoided by taking a little bit of care over developing the code, developing your software, and not just focusing on that output. Sort of more realistically, sort of less of a horror story, is beyond kind of publishing papers, the code is used sort of very much in control and decision making. So relevant for us, I guess, is weather forecasting. Probably everyone looked to see whether it was going to stop raining before they walked or cycled here. We've got climate policy informing the CMIP reports. More recently, sort of disease modeling. There was a lot of debate, I think, in the news when people were using pandemic models to model the spread of disease, about how accurate or not these might be, satellite spacecraft, etc., which is to say that you have no idea where the code that you're writing now might end up someday in the future. And as a side note, people may know who this is. Anyone? Yes, and it was indeed Margaret Hamilton who was the first person to coin the term software engineering. It's a fun fact. So again, I'll give you maybe a minute. Can anyone tell me what this code is doing? Anyone? So exactly the same code. Can anyone tell me what this code is doing? Yes. Yeah, thank you very much. So I'm sure lots of people are familiar with being given code like this, or maybe writing code like this, coming back to it 2 weeks, 2 months, 2 years later, wondering what the hell you were doing and what this means. If you'd got exactly the same code doing exactly the same thing, you can see all the highlighted lines of code itself are identical-ish, with a couple of extra bits here. It would be much easier for you to pick this up again and get going. So this is the sort of thing we're looking to move towards over the course of today. So we'll start off with virtual environments, who here uses virtual environments when they're writing code? Super, a few people. So virtual environments, has anyone ever been in the situation where they want to install something in Python and you look, you clone it off Git, you try and run it and you find that, NumPy was upgraded to version 2 and you've only got NumPy 1.9 and everything stops working and you have to try and fix this. So you install NumPy 2, which is all good, but then you go back to the code you were working on 2 days ago and you find that it doesn't work with NumPy 2. Yes, some people nodding. So the idea of virtual environments is to sort of prevent this happening. And we do that by sort of doing all of our software development within our own little sort of walled garden of software, our own garden of dependencies. So we're going to think about this in terms of Python, but I will give you pointers to how this tracks over to other codes sort of as the course goes on. So what a virtual environment does is it sort of creates Python, instead of pip installing it just onto our computer in this giant cesspit of everything you've ever installed, it will actually say, no, I'm going to install it into this specific folder. When you're developing your software here, we'll use any dependencies from this folder. But then if you want to go and develop some other piece of code, you have a separate environment in which you do that work. I would suggest that you use this kind of on a project-to-project basis, meaning that everything gets kept nice and clean. The other advantages of doing this, other than kind of pollution and messing up your dependencies, is that it also allows you to improve the reproducibility of your code. So if you wanted to set specific versions, for example, I mentioned sort of there's the upgrade from NumPy version 1 to version 2. It can allow you to sort of pin that down into different research projects, should you wish. Python, there's a lot of ways of going about this in Python, as is the case with many things. We're going to use the kind of inbuilt to Python virtual environment system. And you can explore the others sort of at your own leisure. But if you want to follow along at this point, we'll be going through exercise 1 here. And I'll just show you what we're doing. So in the location of our Git repository that we cloned a moment ago, and if anyone can't read that, please put your hand up and let me know. We can use Python -n. Yep. And then we use the venv command, which is going to tell us to, yes. Yeah, so I said there's a few ways of managing this. Conda environments are a different way of doing exactly the same thing. So if you're comfortable with using Conda, that's great. Today we'll be using venv, and you might want to learn this as well. But yeah, it's a similar idea. Did you try the SSH clone? Because it might be that if you try the HTTPS, you probably should be able to clone that. Okay, so we've got Python, which is going to run our Python, because this is an inbuilt command, venv, which is the command to create a virtual environment, and then we have to give it a name. My suggestion for this is going to be RSE venv. Try and give it something relevant to the project you're working on, and this will become clear why in a second. Oh, it may be that we need Python 3. So that might depend on your particular system. So if you do that, what you should find is that we've now got a folder created called RSE venv. And I said before, what this is going to do is install anything from Python into a separate location from our sort of global place on our computer. This is that location. And so anything you now pip install will be placed here rather than onto the bulk of your computer. So the next step is to do what we call activating that virtual environment. So at the moment, all we've done is create the folder, but we need to sort of enter that walled garden of software dependencies. And to do that, we're going to run the source command, which is going to sort of run a little script for us. And then we want to, this will be located in the RSE venv inside bin. And in then, if I can type, the activate script. So if we run that, you'll see now there's this little pop-up to the left of our cursor. And that's the name of the environment we've just created. And that's now telling us that this environment has been activated. We're now inside that, and anything we install is going to be sort of safely placed in here. If you're using something other than Linux or Mac OS, there's some slightly different commands for Windows, and you can find those there. So anything we now do will be done within this virtual environment, but suppose we want to come out of this and work on a different project. The command we want to use to do that is deactivate. If we run that, you'll see that the code to the, or the little pop-up to the left-hand side has now disappeared. And that's indicating to us that we're no longer in that environment. Anything we might have installed into that environment will no longer be available to us, and we can move on to work on some other project somewhere else. However, everything's not lost. If we then want to come back and work on this, all we need to do is go back to that command sourcing the virtual environment, run that again. You'll see that we're booted back into that environment, and everything will be exactly as we left it with all of our dependencies ready to use. If at some point you decide you want to remove that virtual environment and start again, then it's just the case of deleting that RSE venv folder that was created. So you can remove that, everything will be blown away, and you can start again. Also, if you wanted to create two separate virtual environments, maybe to try out different versions of a software package, you can do that from within the same folder. We would just choose to name it something different, like RSE Venv 2. Oh. And you'll see now that that folder is also there, and we could activate that. Okay. So I did say we'll have pointers towards other languages that you might be working in besides Python. So someone has already mentioned for Python, there's a few options. Conda is an equivalent one. Conda will do Python. It will also do other languages as well. So that's maybe an advantage there. If you're working in C++, C or Fortran, if you're doing this on a cluster or a HPC system, this is kind of the same thing that module environments are trying to do for you. So when you do module purge, module load, you're actually specifying the specific versions and the specific packages you want to work with. I'm sure anyone who works with this sort of stuff will have found sometimes you load one version of NetCDF and your code won't work. You have to load the other version, etc., etc. These are often managed underneath by SPAC. So SPAC is a package manager, but it does also have the ability to build software environments for you as well. And I would suggest anyone interested in that goes and speaks to Tom, who's sat over there. Finally, those developing in Rust, there's very good inbuilt package management with Cargo. Julia aficionados, I believe there's a package environments, though I would point you to Adeleke at the back to discuss that a bit more. And then finally, if you're working in R, they have a similar system to Python, but as is sort of the trend with R, everything has to start with an R, so it's the Renv system. So that brings us on to exercise 1. There's a sort of a scenario or a theme that's running through the workshop today, which is that you've been given some code by your colleague to do some plotting of the results of a climate simulation, and it's going to sort of read in a NetCDF file, do some data analysis on that, produce some figures that you can then use in your work. So this is good. We're reusing code. We're not reinventing the wheel. But once we get looking at it, we're going to find that sort of some of this code, like we discussed at the start, is a little difficult to understand. So from the code that you've cloned, if you take a look, you'll see there's an exercises folder. If you cd into exercises, you'll see that there's different numbered exercises as we go through. We're going to start off with, funnily enough, exercise 1, which is the base code. And within this, you'll see we've got a file, which is precipitation climatology. So if we open that in whichever text editor you prefer, you'll see that it contains a bunch of code that are doing some things. What exactly, we will find out shortly. So the first exercise, if you haven't already done so, if you can create and load a virtual environment, and then have a go at running the code. I'll give you maybe 5 minutes for that, and then we'll come back and have some discussion. Did any problems yet they want to share, or any difficulties? There are supposed to be some, so you're not doing badly if you have. So has anyone run the code yet?
Yes, I've got some data that's at an absolute path we don't have. Oh, I've got the wrong problem.
Possibly.
Let's start.
To try and import this.
Okay, so in the interest of time, if we can come back and we are going to finish off this exercise, but this brings us sort of on to the next bit of what we want to talk about with environments, which is kind of some basic ideas around packaging. So when we talk about packaging in software, this is the idea that in order for you to be able to run code on your system, giving you that source code or giving you that data isn't sufficient. You're also going to need a whole host of other things, such as information about all of the other packages it depends on. And so you'll see, probably as you found when I initially tried to run this, I get problems with modules not being found, which comes from all of these additional dependencies that are needed at the top of the code. And so the hard way to do this is to go through one by one, trying to run it, installing the thing that's missing, trying to run it again, hitting the next problem. But what's a much, much better thing to do, especially when you're sharing code with other people, is actually to give them this information up front. So in Python, this is, again, done in a variety of ways, but the most simple one that I'd encourage you to get started with if you've not done it before is providing a requirements.txt file with your code. So this usually sits at the top level of the repository somewhere, and it lists all of the packages that you need to install in order to get that code to run. So you'll see here, or maybe I'll show you on GitHub. So you'll see on GitHub, this is listed at the top of the repository, and it contains sort of the text of all of these missing packages that you've probably had to try and get it to working. In addition to specifying the packages, we can also actually constrain the versions here. So if you had a problem running, say, with NumPy 2, and you need to constrain your software to NumPy version 1 point something else, you can do that by specifying something here, either a less than, an equal, or an exactly equals, to achieve this. And typically, we say we specify kind of the top level dependencies. So you might find when you install something like, I don't know, matplotlib, matplotlib itself will then go and install a whole bunch of other things, but that's because matplotlib has been properly packaged, and so it knows where to go and fetch all of this. You don't need to specify everything under that, you just need to specify matplotlib itself, and Python will work out the rest. And there's a handy command within Python, or within the pip package manager, that will go and install all of these at once for you if you give it a file. So you can see we can run pip install -r, which is going to say run recursively through this file and install everything you find. And then give it the list of the file that you want to run that for. And hang on, let me. And because we're in the exercises, that's now 2 levels up in the directory. So if we run that, it'll go through and fetch everything we need for this. And you should now find that hopefully, without any further work, we're able to run our precipitation code without many other dependency problems. It might just take a little while. There we go. So just before we move on from that, what I would encourage you to do now is when you're developing your code and you find yourself having to pip install something, maintain what you've pip installed somewhere in a requirements.txt file, so that if you come to boot this up at a later date, you can get all of those dependencies back quickly. And if you're going to share this code with anyone else, you can give them this as well, allowing them to get started straight away. So hopefully, if we have a look in exercise 1, you will now find that in addition to the code, this has dumped some stuff out. So we've got a couple of images. Actually, what have we got? We've got some information about zonal averages of some variables. We've got a data file looking at precipitation in different countries over different years. We've got some kind of estimation of ENSO, though there's probably some things in there that could be improved. And the main thing labeled output is we've got this sort of C-masked distribution of precipitation across the globe. So the outputs here aren't too important. It's code that produces something. As I say, what we're looking for in this workshop is improving that code itself. But is everyone got to this point of producing these graphs? Super. If not, please do stick your hand up and someone will come and give you a hand. Yeah, so exercise 1 we visited is exactly what we've just been doing. And I do say at the end here, deactivate the environment, but I would suggest leaving that environment open because we're going to be using the same code throughout the workshop. Okay, yes. If you don't name it. So when you switch it off, the computer itself will deactivate the environment because it's when you run that source RSE bin activate, you're running a shell script that kind of sets up a number of environment variables for you to direct Python to install things in the right place. If you turn the machine off, it'll kind of lose that state. So if you boot back in, you have to then restore into that environment. Throughout the day, if you're not shutting your machine down, there's no reason not to come out of that environment. But if you're sort of hopping between 2 different projects or 3 different projects, as I say, I'd encourage you not to use kind of one environment for all of those, but have an environment that's shared across all. Because it's quite, once you've set them up, it's quite quick to activate, deactivate, that sort of thing. But yeah, it's a good question. Super. So the next thing we're going to move on to is talking about sort of formatting of code. So whilst you've been looking at this, one of the questions sort of I was meant to ask was, did the code do what people thought it was going to based on looking at the source code? Or phrased a different way, could we perhaps improve some of the source code? Is it easy to understand? Yeah, good answer. So I say pull up, that one has one. Yeah, here we go. We've got something plot ENSO. We can probably infer that this is going to do something with plotting something to diagnose ENSO, but it's not really clear what that function's doing specifically. Sort of, is it annual averages? Is it sort of Hofmöller, etc., etc.? So the main thing we're going to look at first is around kind of the readability of that code. And here we're just going to sort of take a moment to introduce the Python PEPs, which some people may have heard of, other people may have not. So these PEP is short for the Python enhancement proposals. And this is kind of when the Python community comes together to discuss what things should be best practice, what things should be standards, and develop kind of a variety of technical documentation. Most of these I won't worry about too much unless you're really interested, but there's a few that do pertain to the actual development of code and helping with that. So the first one of these, which we'll be looking at now, is the Python style guide. So this, I think you can, don't do that. So this you can find, there's a link and a reference there. And this pertains to sort of how your code should look, making it much more readable, much more usable, and just kind of a consistent layout. The second one is the docstring conventions. So as our friend at the back mentioned there, this is to do with how you should be documenting your code in a consistent way. And indeed, we'll come on to that in tomorrow's exercise. And the final one here is around packaging. So that's PEP 621. And we sort of mentioned in the previous exercise these ideas around providing a requirements.txt. If you actually want to make your code much more widely distributable, there's a whole host of other things. So you're maybe familiar with when you run pip install numpy, Python's just able to go and fetch that sort of from space. You don't have to git clone, do everything else for installing NumPy. And that's because NumPy has actually done a lot more. There's a lot more infrastructure around this, which is covered in 61. So that's a pointer if you want to read a bit more about this, if you're thinking about making your code more public, but will be beyond the scope of this week. So readability counts is something in the Zen of Python. If you've not come across it before, just a quick Easter egg for people. I think if you do import this, no, can I remember the command for this? Tom? How do you get the Zen of Python? Oh, anyway, maybe we can open it here. So the Zen of Python, it is. Oh, you have to run it from within Python. Okay. The Zen of Python is sort of this little poem composed by Tim Peters, which gives us sort of an underlying insight into what nice code in Python should strive to achieve. And the thing that we're particularly focusing on in this exercise is that readability counts. And this is sort of often summarized in sort of the other adage that maybe you've heard before, which is that code is read far more than it is run. And particularly if you're collaborating with other people there. So when we look at PEP 8, which we will do in just a second, you'll see that by ensuring our code sort of aligns with the guidelines set out here, we actually conform to a standardized style. We meet any best practices that have been set out. So not only are we writing readable code, we're trying to write good code. And through doing this, it kind of makes our code easier to share with other people, to come back to ourselves, and helps kind of reduce any confusing or misinterpretations we might have in which we sort of share our code and someone uses it in an inappropriate manner. So yeah, I do want to just open. Yeah, so here we are. So this is PEP 8, which you can get to from the links. And as you scroll down, you'll see there's a whole bunch of things that describe how Python thinks you should be writing your code, along with kind of examples of good code and examples of bad code. So the first one is around indentation, but if we go a little bit further down, there's a few other things. So the suggestion that when we do imports of packages, we should try and keep these on separate lines rather than putting things all on one line. And there's some explanations of why this is the case. Let's see. Okay, excellent. So white space is a fun one, which if you've not come across this sort of thing before, maybe you've spent a huge amount of time whilst you're writing code, making sure that you put white spaces between operators or where you think it's sensible to do so, coming up with your own set of conventions. Maybe when you list lots of things on a line, you kind of list 4 things and then decide it's long enough. So you go to the next line and start listing more things. In this document, there's actually examples and advice on how you should specifically do that. So here you can see the idea that you should have spaces after colons in a dictionary, but not spaces after all the things. Things should butt up to brackets. And as I say, there's a whole host of these things. And so your question at this point might well be that no one in their right mind has time to memorize all of this and start implementing it in their code. And how are you going to get it right all the time? And so that's where sort of the first of the tools, second of the tools, if we count the virtual environments as one, comes in. And this is called rough. So what this is sort of a little package that will run over any source code that you provide it and actually take that and enforce the rules that we've just read all about. And it will do this in kind of a strict, opinionated way. So all of them will be enforced in the same manner. And you don't have to worry about making sure everything's correct. It will do it for you. There's kind of full details of things on their style guide, which is provided online, because there's a few things that sort of the PEP 8 leaves a couple of options open to. But in order to kind of reduce misinterpretation, Rough makes a decision about what the correct way to do this is. And finally, the last thing to point out is that this is going to run over your code and change the layout, hopefully so that it's more readable and it's more standardized. But when you do so, it's not going to change what your code does. So all it's going to change is the layout and the white space, the locations of blank lines. One of the things sort of that's key to this tool is that the code itself will remain exactly the same. It's not going to change, introduce any bugs or unexpected behavior. Any questions at that point? No. So we're going to try this on our code and see what it does. So in order to get rough, let me move that. Sorry. So in order to get rough, as I said before, you can get it from pip. So we can run pip install rough. And doing so will pull that down with anything we need. And you can now check that. There you can see, and you can see, as I mentioned before, when we've inquired as to where the location of that package is installed, if you'd done this just from your base environment, it would have been somewhere in kind of etc/python/something. Whereas you can see this time it's been installed into this RSE ven file and in its own kind of list of binary directories, so separate from your main code. So if we've installed that, the next thing we need to know is how to run it. So there's a few options. As I said, we're looking at running the formatter here. So to do that, the command is rough format, and then we can give it either a specific file we want it to format, or we can give it a list of a directory, and it will search recursively under that directory for all of the Python files and apply the formatting. The other thing to say before anyone gets too keen trying this out is that it will modify these files in place. So the assumption is that you're running this because you want your code to look nicer and more standardized. And so it will just go into the source code, modify that file, and overwrite it in there. Of course, if you come along this afternoon to use Git version control, you know exactly how to get that file back should you do this or should you desire. As a quick example here, like I said, these are two pieces of code. On the left is that one. On the left, we've got kind of this ugly, badly formatted code. And if you were to take this and run the rough format over it, it would be output like this. So we can see there's a few things to look at. Like I said, often you find people have sort of spent a huge amount of time kind of deciding how to line up their imported parameters onto kind of line length that's not too long, but sort of looks nice. Rough will go over this and say, no, one per line. Here we are, you can read it straightforwardly. You don't have to sort of sit thinking, oh, I've got param3, where's that coming? It's somewhere along here. No, it's just in one long list like that. Similarly, we mentioned there's kind of this white space around operators. That's been enforced was there. All of these inconsistent sort of use of blank lines, that's been cleaned up sort of to be more standard and more readable. And a few other things besides. Yeah. Yep,
Right.
it is. So this is to do with how Python chooses to format things. So if you want kind of a long list listed with one parameter per line, the way of enforcing that is to have a comma after your final item. We might see this in the exercise, I can't remember, but Rough does, so Rough will say if you've only got, say, 3 parameters here, it feels that that is acceptable to have on one line. The problems with readability sort of come when you've got lots and lots and lots of things spreading over multiple lines. It says, once you're spreading over more than one line, you may as well have one per line. And yeah, the comma at the end enforces that. So if you only had 3, but you still wanted it to be one per line, you can use that trailing comma. Yeah.
I once had a nasty bug which I just couldn't understand, and I've seen it here as well. Param2 is initialized to an empty list.
It is indeed. Hold that thought for about half an hour.
Yeah.
Less than half an hour, maybe 15 minutes. Okay. So again, I was mentioning sort of there's other languages. So we're talking about Rough here. Rough is kind of recent, well, within the last 3 or 4 years, come onto the scene and has kind of replaced what a lot of people were previously using, which is Black, which kind of does exactly the same job. If you're working in C or C++, the Clang compiler, they provide Clang format, which you can use, and it will do sort of a similar sort of thing with your C and C++ code. Fortran doesn't quite have anything yet, but there's a package called Fortitude that's currently in development to try and do this for Fortran codes. Rust has Rust format, of course it does. Julia, there's some tools, and R, style R or R, because everything has to have an R. And like I say, we won't cover these today, but I'd encourage you to go and have a look. They follow generally the same principles. You run them, point them at a source file, and they'll do all the rest of the magic for you. Just the implementation might be slightly different. So I think Clang chooses not to overwrite by default. You actually have to force it to do so. So exercise 2, if we navigate to that, so all of the exercises are in different folders. You can work on the same code in one folder if you want, but if you get behind at any point, there's always sort of a new starting point in a new numbered folder, so don't worry about that. So what I'm going to do is go out of here into exercise 2. And you can see in here, if you want to have a quick play first of all, there is this longfunc.py, which is the example code we were looking at a moment ago. If we run rough format on longfunc.py, what we will hopefully see is after we do so, it gives us that feedback that it's reformatted one file. And now over here, if we reload this, we can see, bang, there we go. If you have a go at running rough over maybe initially this, and then the precipitation.py file, and see what it looks like, have a go through, see if there's anything you think is more readable. If you want to compare it to the code that was previously being used, you can open side by side in a text editor the code that you've modified, and then the code that's in the example 1 folder for side-by-side comparison. So I'll give you maybe 5 minutes to do that. Again, if anyone has any questions, stick a hand up. Or any observations of what's maybe got better, what's maybe got worse. Is it a using question?
Yeah, so I've installed Rough. I've checked it's on my hit list, but when I run it, it says command not found.
Are you running rough or rough format?
Is that
So rough is a package, but it contains other utilities as well, which we'll be seeing later.
okay?
So you specifically want to format your code, so you need to run rough format name
Yeah,
file.
that's what I did.
Ah.
Yeah, Rough format, and then says.
Okay. Let me. Yeah, it seems it wasn't picking up the correct version of Python.
Okay. Okay, yeah, that might be why I had to.
But if you, yeah, if you come.
Yeah, because I tried this before and it wasn't working, so I had to put.
So that's because we've not made. I don't think we've made the file executable.
Okay.
But it, yeah, if you speak to someone over the coffee break, we can have a look at that for you.
So I just type Python-m.
Yeah, it's telling it specifically which to look
Okay.
for. But we would hope that it should pick up the right thing.
Yeah.
But unfortunately, but for the rest of the exercise. Yeah. Okay, if we come back to continue, hopefully most people have got to where we're going by now. Is there anything anyone wants to feedback about what's been done? Anything that you think is better? Anything you think is worse? Anything you have contrasting opinions on? And I will load up. Yes, Sophie. The two spaces here. Yes, it has. If you look at the full documents for the PEPs, it probably explains this in there somewhere. Normally, this is because kind of your imports are one big separate thing that you might want to look, and so two spaces adds a bit more distinction between them and the rest of your code. Because you'll also find with some things, and I think we'll maybe see this later, sometimes you might want to break up your imports as well. So you might want to say, here are the things I'm importing that I've installed from pip, but here are things I'm importing from local files. And so you might have a white space between those. And so to finish it off, you might have the double white space. But yeah, it's a good question. And you'll see sort of between functions, there's two lines of white space. But then once we look at maybe in classes, if you've defined a function within a class, there it says you want one line of white space because it's sort of contained within something. But yeah. Anyone else? Anything? Yeah.
Yeah. So there's like a commented out if on line 178. Yeah, look at that. So if I uncomment, if I was to use, I don't know, command / to comment that region, I'd lose my indentation if I hit.
You would, yes.
Ooh. Well, having said that, keeping all that old junk in there anyway, that's under version control, is very good.
Indeed. And if you come back tomorrow, I think this is under tomorrow's session, we will talk about that. But yes, keeping any old junk in there is not sensible, especially if, as we'll see this afternoon, we're using version control in our code. Super. Yeah.
Yeah, on line 110 for the bot end zone, the way that it spaced out the dot select didn't seem very intuitive to me. It seemed like it would make more sense to have it still on one line. So.
Yes, let me. I'm now trying to remember. This is, yes, the right hand will be the old code. Yes, so like I say, it is opinionated, and there are multiple ways that it would work. The argument I think they would make is that this line's then becoming very long. So you can see in the text editor here, it's sort of running off the end of the screen. And I think probably, so one of the rules it enforces with formatting is a maximum line length, I think, of 88 characters. And so you can see here as we go along, sort of this is blasting past that limit. So the limit is indicated by this red line here. It's going past that, so it said, whilst this could be on one line, we feel it's too long to be readable in a single text editor as you're just going up and down the code, so we'll move it over. It is possible to configure this, so if you did want a longer line, you could do so. But it's a similar argument to sort of the when we have multiple function inputs, it's saying at some point, if we've got to break it up, let's kind of break it up so we can read it sequentially. But one thing I would say is when I first started using formatters on my code, initially a lot of my code looked weird because I was used to how I liked to format things. But if you persist with it over time, gradually you become used to kind of reading it in this layout. Yeah. Super, yeah.
Demonstrate how
Yes, we will be doing that momentarily. Okay, so if that brings us to the end of exercise 2, the next thing to talk about is static analysis. So we said when we ran the formatter here, it will change how our code looks, but it's not going to make any changes to how the code runs or what the code is doing, because that would be bad. But this is where static analysis comes in. So here it's saying beyond just how the code looks from Python PEP 8, it's actually about improving the quality of the code that we've written. So this is kind of about learning. There's an advantage here as well, which if we're using the tools that we'll see in a moment, it'll also teach you about better practices whilst you're writing your code, so that hopefully you kind of don't make these mistakes going forward because you've seen them now before. And the other thing is that this will save us time. So how many times have people sort of set a piece of Python code running, gone to make a cup of coffee, only to come back and find that there was, I don't know, a missing constant or a missing addition sign, and then you've got to run the whole thing over again. So the idea of using static analysis is that it will look at your code just as it sat there, hence the static, before you do anything, and it will try and catch as many of these problems before you actually set it running to try and avoid this. So again, even within Python, there's a whole host of tools available. As listed here, since we've already installed Rough, we'll be using that. And it's the way I would encourage you to go. Sort of when we delivered this last year, we actually used some of the other tools, but the growth of Rough has kind of implemented the features of many of these other ones. Particularly some of them, I think Pycode style actually became deprecated a couple of years ago. So I would encourage you just to stick with that as kind of the one tool to rule them all. So previously we ran rough format. To run the static analysis checker, we run rough check. Like I say, there's nothing else to install. So the code quality, so the first one here, can anyone spot if we want to try and run that code, is that code going to run, or is there anything that's going to stop it? Yeah, so we hope that people don't spot that quickly. But indeed, so here in the code, we've got param2, we're doing some calculations and then appending to this list that's defined in param2. But the problem is param2 is never defined in our code. When we wrote it up here, we passed param TWO as this list, which, yeah, when you run it, it's going to complain. But actually, this is quite difficult to spot for a lot of people. Hopefully, a few people didn't see that immediately. So what happens if we run rough check is it'll spit out some information for us that gives us sort of a list of complaints about everything that might be wrong in our file. And so the first one of these, exactly as we say, which is going to kind of cause a terminal error, is the fact that we've got, well, the last two of these, sorry, are going to cause the terminal error, which is that we've got this undefined parameter 2. But then this is sort of linked into this first warning. We can sort of piece the puzzle back together, that it's also warning us that we've got this unused argument into our function param2. So by either renaming this param TWO, which is probably the correct way to go to be consistent with the numbering elsewhere, that'd be a good idea. Similarly, param3, I guess this was maybe used for something else in the past, but we've now taken that out. And it's now just sitting in there as junk code being defined at some point, clogging up what we're reading. So we can also get rid of that there. And the last one, which we've got here, B006. Yeah, so we can clean those up. And if we run rough check again, we'll see that those have now gone away. But we've got one problem here, which is that we've got B006, which is, and sorry, I should have gone through, it's telling us that this is occurring on line 4 of this file. So line 1, 2, 3, 4 here, and it's a warning that we shouldn't be using mutable data structures for argument defaults. And so I would ask at this point, does anyone know why this is? But perhaps.
Oh, yeah. So if you call the function twice, then if that list has got stuff in it now, it will remember the stuff the second time you call it from somewhere else. You'll be surprised because you expect it to start with a new empty list, but it doesn't. It uses the same list each time.
Yeah, so to repeat, for those who perhaps didn't hear, when you call this function for the first time, it'll be an empty list. When we call it the second time, we would expect it to be an empty list. But in fact, because of the way Python works, it won't be. It will retain anything we've added to it in a previous function call. So like I said, as well as spotting errors, using static analysis will also give us things that sort of try and avoid these potential bugs or encourage you to write better code. However, I don't think this is a particularly instructive error message here. If you wanted to know more about this, if you get a report from running rough that gives you anything you don't quite understand, and let me, come out of this. What we can do is run rough rule and then B006. And this will give us in our command terminal sort of a nice little example of what this rule is with more documentation, why this is a bad thing for you to do in your code, a couple of examples of how you would not do it and then how you would do it, and then some references to documentation to read more. So if you ever see something that doesn't immediately make sense, you can check it sort of right there on the command line, or you can go to the rough documentation where they have sort of that thing replicated but in a jazzy HTML, CSS format. Yeah, so a slight aside here is to say that if you're using an IDE in which to develop your code, there's a lot of plugins that will actually allow rough to be continuously running in the background. And I don't know if I have this set up because I'm using a nice yeah, I don't have this set up here, I'm afraid, because I'm using a simplified setup for this course. But you can get a lot of plugins for whatever your particular IDE of choice is. VS Code, of course, everything's in there. But you can also find these in PyCharm or Vim or NeoVim, Emacs. There's a way of setting this up so that a bit like when you're typing in a document and you've got a spelling or a grammatical error, it will underline sort of things and then give you a hint as to what the problem in the code is before you even get to running that code or running the static analysis. And so this can be really nice for kind of teaching you things as you go along, and gradually as you fix these mistakes, it'll coax you into becoming a better coder. For example, I remember when I worked as a postdoc, I had mutable arguments in all of my function calls. But after being told about this enough times, I've now just sort of reached the point where I know that, no, I pass it in as none and then initialize it within the function. So again, other languages, there are tools to do this. So C++ and C, we said there's Clang format before. We've now got Clang tidy. Also C++ check you can run, I think, as a Python utility you can install. Fortran, so Fortran has Fortitude. For static analysis, this is up and running. So I very much encourage you there. Rust's got Clippy, and then R, of course, has lint-r. And more generally, if there's a language that's not been mentioned here, there's this big list of static analysis tools. that's not currently up, but you can go there and find stuff for whatever language you might be writing in. So the next exercise is to do this. If you go to exercise 3 and have a quick scan through, try running rough check over a few things and see what things look like, what things can be fixed. I'll give maybe 2 or 3 minutes for this for you to have a quick go. And I think, as before, in there should be also that long func again, so you can see what it looks like if you run on that. One thing particularly to say is if you run this just as rough format, it doesn't give you the output quite as we saw it. I was using the concise format in the examples, but it will actually give you a lot more information, pointing out specifically where in your code that problem's occurring. So if you go to exercise 3, have a quick couple of minutes, but we are getting a little short on time, so that might be an exercise to be done this evening or before the workshops tomorrow morning. And so whilst people are doing that, I will also go over, someone asked about configuration a second ago. So when you install rough, by default, no, sorry, I'll give you a moment to do the exercise. Now I'll come back. That's bad of me, sorry.
I was worrying about configuration because I did install the VS Code extension, which immediately worked, but it's highlighting some things that were formatted by doing the command line version. So I guess they're using slightly different configurations. So it's complaining. So sorry, some things are kind of static errors, but for example, it's saying low blank lines allowed after function docstring. But I've already run rough on formatting.
Yes. So there is a reason for that. So rough format will apply its opinion about blank lines when it thinks they're definitely wrong. So for example, between functions, there should be 2 blank lines. After dot strings is a bit more of an opinion. So you could have a blank line, but others might say not. And so it sort of says either acceptable. So if you've chosen a blank line, I'll leave it as it is. But there's some additional rules that we'll look at, I think, tomorrow, that actually apply more tight constraints around the dot strings. But these are kind of static analysis rules rather than format rules.
Okay.
Okay, so I'll let people finish that sort of in their own time. It seems that everyone's roughly getting on with it, and talk briefly about configuration. So when you install rough, if you've not done any other setup, you'll find that the set of rules it kind of implements is actually quite simple, and probably you're going to want a lot more. And so the way of doing this is you define kind of a list of all the rules, or the list of all the different rule sets that you want to apply in a configuration file. So this will normally be called rough.toml at the root of your project, though if you've got more advanced packaging, this might be within the pyproject.toml instead. And there's a whole guide on this in the documentation, but I'll just briefly go through this, have a look at this here, which is, if we go back to the root of our project, you'll see that we've got this rough.toml. And if we take a look in there, you can see there's laid out according to the documentation online. So if you want to look at other options, I'd encourage you to explore. But we've got a set of rules. So the first one is setting the line length. Like I say, the default is 88, which I think is common across Python. But if you disagree, you can set something else here. We've got some other things in here, setting up docstring formats. But the main thing to look at is here where we have linting. So yeah, linting is a synonym for static analysis. Don't know why tumble dry is yeah. But here we have this list of different rule sets. So if we go to the rough rules documentation, you'll see down here is kind of description of all the different things you could enable. Each of these has a sort of little acronym shortcode. And by listing these in the select, you tell it what you do and don't want to check. And then we can get, these are kind of entire rule sets. If we want to get even more specific, we can specify individual rules as well. And then at the bottom here, if we want to look at our doc strings, we can set a particular convention, and we'll come back to this tomorrow. So one thing that I will say is moving forward for tomorrow, we're going to add a couple more rules now that we hadn't enabled initially because we didn't want them cluttering up the space. So we're going to add D, which is the PyDoc style rule set. So we can do that here by adding, if it's going to let me. Oh, it has. So adding another item to that list, which is D. And for tomorrow as well, we're going to now stop ignoring these two rules down here, which you can go and look them up in your own time, but they will be for things that we teach tomorrow. Tomorrow afternoon, and there's a wonderful spreadsheet online that you can use to check. So if we save that and you run rough check again, you'll probably find that there's now a whole host of other warnings that are complaining at you. Don't worry, we'll deal with those later. And I'll pass over to Marian.
Great. Don't worry, I'm not going to talk long this morning. I just have a couple of more things to do about to talk about structuring your code, and especially in the terms of, okay, what can you do apart from using these tools that do all kind of nice formatting, also to make your code more readable and easier to use by others. And I think the most obvious thing that most of you hopefully are using already is structuring your code using functions. And obviously, you don't want to basically have the same part of your code being repeated again and again. One reason is that it's bad style, but then the other reason is if you find out a better way of doing something, or you figured out there was a bug at some point in this piece of code, you would need to remember to update all the little copies that you have distributed across your code and make sure that you remove the bug all over there. But then the other reason is simply readability, and we are coming back to this issue again and again and again. It's really important that people can look at your code and see immediately what is this chunk of code doing, and where can I then reuse this maybe, and want to if I want to do the same thing. The last reason is that you might want to use your piece of code as a building block. For example, if you have a fluid solver, so you might want to switch in and out different solvers, want to try out different things at this point. So having a function that does something similar in different varieties also can be really useful for this. And you might also have heard about the separation of concerns or the single responsibility principles. If you want to be really good, a really good software developer, you should make sure that your function is not doing 3 things at the same time, but that your function really does this one thing. And if this one thing changes, then you do it in one place and you don't have like 3 places to do this, or you have other things that might be interleaved with the one thing that you want to change. So just a very small example here. This is the pendulum equations we might have seen already today, or we will see tomorrow. You see here on the left side that there's lots of stuff of functions and numbers and so, and then on the right side we tried to improve things slightly or make it more obvious what's actually happening down here, for example, or what's happening in here by introducing some additional functions. So where I'm highlighting here on the left the parts that we want to add functions to. So we have the get period function here that has this long piece that you can see on the bottom here, for example, or also you reuse it here. We've added a constant for the gravity here. We're talking about magic numbers tomorrow. Here we've got a bit where we have replaced this bit here, given it a name to tell people, okay, this is actually what we're computing here. And then here you can see where we've then replaced these tangled up bits by something that makes it a bit more clear. Okay, what are we doing in this piece of code? So how are we, what are we computing here? What are all these numbers about? There is more stuff that we can do about structuring. There are modules, and also you might not want to put everything into one file or so. So just to make it easier to find things without scrolling through one mega file. And if you want to basically grow your thing into a bigger code base and step away from just having one big script for everything, then going about having a structure of files and modules really improves the manageability, and you will be able to easier extend your code to plug in different parts. Maybe you want to couple 2 different code bases or so. And then importantly, and we'll have this later on this week as well, it makes it much easier to test if you have a well-structured code where one thing does one thing, and you can really check that everything is done correctly. So just a final exercise for today. If you go to exercise 4, you have find a little script that's doing some plotting. And I would like you to just go into there, and we'll just have a minute or 2 to do this actually, and think about what you could do to improve the code, how you could structure it better. And then also maybe have a little think about, okay, if I've restructured the code in this way, what does it enable me to do? So what does it make easier, or what additional thing can I do that way? So I'm watching the clock to just give you a minute or 2 before I show you some examples, and then let you go off and have some coffee before the keynote. So by a first look at the code, does anyone have any ideas what could be improved? Okay, there was also something here. Has that already been said?
Oh, simple saying it's a lot of duplication, and yeah, X is repeated many times.
Okay, thank you. So now, oops, trying to find the right one here. Is it Sublime? Okay. Okay. This is just a small attempt of doing this. Probably you could do many more things. And I think when we discussed this exercise, Jack had loads more ideas what could have been done and added. But you can see here on the right that I've just created a little function that does this 2 times 2 plot and has the array as an input, and also the number basically it's defining which of these subplots we're talking about, and then I'm just looping over this, and I've created these little arrays for defining different markers and colors and line styles to plot the same thing. This way, of course, you can do lots more things. So you can have lots more formats and having functions to do things, and also putting in lots more things. But you just can see, so if you have something on the left here, you would need to, if you figure out the different way of, you're laughing. If you figure out the different way of doing things, you would go into each of these repetitions and changing it, whereas on the right side, you can just simply go and make this one change. And also in terms of readability, also it's some improvement. Okay, running out of time. Where do I have my slides? Check.
You stick on there and I'll find them for you. If you just come back here.
Okay. Yeah, okay. So that's for today in the session. Tomorrow in the evening session, I think that's the 3:30 one or so, we have some more things. These are just our how to reach us. You can also reach us on the Slack. Please join the Slack. There's some information about upcoming sessions as well. And there is also the possibility to book some time with RSEs for just one-to-one, sitting in the study room and figuring out why an exercise didn't work, or if you have any specific questions or so. We're here, the two of us, and of course our colleagues in the back as well. So anyone with, well, almost anyone with an ICCS on their badge is very happy to help and to be asked, and otherwise we'll just point you to the right person. We've got coffee now for half an hour, and after that we will have Tamsin Edwards for a keynote. So please help yourself to coffee and pastries or whatever is out there, and then we'll be back in here for the keynote. Thank you.